So norm space function analysis problems this line only. Norm space means you know 4 properties to show R2 space with the norm 1 is norm space. Okay, with the norm that is norm x1 means what? Mod of x1 plus mod of x2. Mod of x1 plus mod of x2, that is norm defined by. Okay, so when norm, okay, to show norm a norm space to show, okay, properties norm space. What is first property? Norm must be positive. Second, norm of x equal to 0, then x must be equal to 0 if and only that elements. Third, norm of alpha x at the 1, then mod of alpha norm of x at the 1, and the point is, you know, norm of x plus y at the 1 is always less than norm of x at the 1 and norm of y at 1. So this probability verify using this norm. Okay, so these questions on MCQ. Third or this fourth important for MCQs. Second example, with the norm to show norm of x2, okay, will be what? Under root of x1 plus x2 squares, x1 square, x2 square. This like norm R2 space, okay, to show it is a norm. Okay, so verify same all probabilities to show norm of x at the 2 must be positive. Okay, norm of x at the 2 equal to 0 if in only x must be equals to 0. Third, norm of alpha x at the 2 position will be then mod of alpha into norm of x the 2 means 2 dimension, this first one dimension, and last norm of x plus y at the 2 always less than norm of x at the 2 and norm of y at the 2. This for MCQs questions. Just like so many problems, we look at the norms. Next, LP space. For example, LP space. So how it is defined? Is a set of x's. I elements are this xi I is belongs to K, such that summation of mod of xi I scalars raised to power p must be less than infinity, means finite. Okay, is a non-linear space. Non-linear space with norm this like norm of x at the p is summation mod of xi I raised to power p then raised to power 1 by p. Solution. Also next example, L infinity, LP space p greater than 1. LP space elements are x's which type, also xi I point, such that xi I belongs to K, such that mod of this xi I must be less than some constant, and with the norm norms are this like norm of x at the infinity, here at the p LP space will be what? Supremum of mod of xi I scalar. Okay, so it's like so many problems. Proof. Just remember, now this space means 4 property you have to verify. Like metric space, you know, in the basic. Banach space. Banach space. Definition of Banach space. A non-linear space, you know already previous topic. Space which is complete as a metric space. Metric space which is complete metric space. Complete, you know, every sequence are convergent sequence. Every sequence are convergent. It's called Banach space. So MCQ also form on this definition. For example, okay, LP space is also Banach space. LP space is a non-linear space. We already show with the norm. Theorem on this, okay, Banach space. The subspace Y of a Banach space X is complete if and only if it is closed. If and only if it is closed. So on this also MCQ can be formed: closed, open, bounded, Okay, so many choice, 4 choice there, and we have to select one of them. We will not take proofs. Absolute, convergent. What about the absolute convergent of the sequence, of course, or series? So a series summation xk here only from 1 to so many in a metric space or non-linear space is called absolutely convergent if summation of norm of xk, summation of norm of xk will be norm of x1 plus norm of x2 plus and so on must be less than infinity. Summation of norm of xk 1 2 3 up to n, that will be less than infinity. Just like so theorem on this absolute convergent in a norm space X every absolutely convergent series is convergent. Absolutely convergent will be convergent if and only if this X must be complete space. Complete, every Cauchy sequence will be convergent. Okay, every Cauchy sequence will be convergent. So then we now take proof for MCQ. Semi-norm, we have nonlinear space. Semi-norm, or it is called as a pseudo. P-S-E-O-D, pseudo norm. You know pseudo metric space in the BSc level. Just one conditions. Hey, so let X be a linear space. Then a real mapping, P mapping from X to R, real, is called semi-norm. If 3 point norm, 4 points, so only 1 point not possible. So P of X positive, first point. Second point, P of alpha X, then mod of alpha outside P of X as in the norm space. Third, P of X plus Y always less than P of X and P of Y. So all three conditions only except one extra condition in the norm, that is okay, equal to 0, then X equals to 0 not. So this is called a pseudo norms or semi norm. theorem on this. So prove that every finite dimensional subspace of norm space is complete. Is a complete space. So many theorems are next time proofs, short proofs.